Now let us look at binary search. For performing binary search, the prerequisite or the condition is that the list of keys or the elements must be sorted. So I have taken sorted list of elements, total 15 elements I have taken. Array size is also 15 and the number of elements are also 15 and they are sorted. So this is the first and foremost condition. So why it is called as binary search? Because it will always check for a key element in the middle of a sorted list and it will split the list into two. So that's how it is binary search. So let us see the working. For example, I have taken a key element 18 which is present here. We will search for this element. If I am performing linear search, in how many comparisons I can find 18? 1, 2, 3, 4, 5. So in 5 comparisons, I'll be reaching there. Now let us see how binary search works. So for performing binary search, we need 3 index variables. So those are lower, higher, and mid. And this mid is low plus high divided by 2, and we will take the floor value. Now using these 3, we'll perform binary search. So what is low? Low should be initially pointing on index 0, that's the beginning of a list, and high should be pointing on the end of a list. So as per our example, low is 0, high is 14. This is initial. Now let us perform repeating procedure. Find out mid. 0 plus 14 by 2, 0 plus 14 by 2 is 7. Mid is 7. Mid is 7. So if low and high are given, calculate mid. Now check if this 18 key element, is it present here? No, this is not the key element we are searching for. Then our key element, is it smaller or greater? It's smaller. So it is on the left hand side. How you can say that? Because the list is sorted. So if the key element that we are searching is greater than this one, then definitely it is on the right hand side. But our key element is 18, so it is on the left hand side. If it is on left hand side, then reduce the list into half. Our list was from low to high till there. Now it should be from low to this point. Already this element we have checked, right? So up to this point. So move high to mid minus 1. So high should be moved here. So this should be high. High should be changed to 7 minus 1, that is 6, and low remains 0 only. So now we have split the list into 2 halves and we are checking for an element in 1 half because the other half element cannot be found. Now continue. Find out mid. Mid is 0 plus 6 by 2, that is 3. So new mid value is 3. Is it the key element that you are searching? Our element is 18. No, this is 15. So key element is greater. So it is on the right hand side of the list. So this is the present list now and this is mid. So the element is on the right hand side, means in this portion. So change this low to mid plus 1. Already we have checked this element, so don't include this one. So low should be brought on 4. So low should be changed to 3 plus 1, that is 4. And high remains 6 only. Now find out new mid. Mid value is 4 plus 6 by 2. This is 5. This is mid. Check. Is it the key element? 21. This is 18. No. 18 is less than 21. Then check on which side of the list. Check on the left hand side of the list. You can observe that the list size is getting reduced and every time it is getting divided by 2. So for checking on the left hand of a list, modify this high. High should be what? Mid minus 1. Don't include this element. So it means low was already 4. High will also point on the same location. So mid minus 1. So 5 minus 1. So 4. High is 4. So low was already 4. Now find out new mid. 4 plus 4 by 2 is a 4. So mid is also 4. Now check. Is it the element that you are searching for? Yes. Element is found at index 4. Element is found. Search is successful. So this is how binary search work. Total how many comparisons it has found the element? 1, 2, 3, 4. In only 4 comparison we got the element. Let us take one more key and search for it. I am taking key 34. So key is 34. The values that we need are low, high and mid. So already you know the formula for mid. Now let us start. Initially low is here and high is here. So low is 0, high is 14. Find mid. Mid value we always get same thing. 0 plus 14 is always 7. So mid will be here. So for this list, mid is always same. Anyway, let us check what is the number there. Is it a key 34? No. Key is greater than this one. So key is on the right hand side. So change low to mid plus 1, that is 8. Now this is the list in which we have to search. So low will change to 8 and high will remain 14. Now again calculate mid. Mid is 11. So mid will move to 11. So we are on the right hand side. So the list is divided into half and we are checking on the other half of it because the number cannot be on the first half. Now check, is it the number that we are searching for? No, 34 is smaller than that one. So it should be checked on this side. So modify high to 10. So high becomes 11 minus 1, that is 10, and low remains 8. Now find out mid. Mid is 9. This is mid. Is it the number that we are looking for, 34? No, that is 33. So the number is definitely on the right hand side. So modify low to mid plus 1, that is both will come on the same place. 9 plus 1, 10, and this remains 10 only. Now find out mid. Mid is again 10 only, so mid points on same thing. Yes, this is the element. So we got that element in 4 comparisons, 1, 2, 3, 4. 4 comparisons, element is found at index 10. So this is how we have seen 2 examples in which search is successful. Now let us take one example for unsuccessful search. I'll take one element which is not present here. So I'll take value that is 25. 25, it should be after 24 but it's not there. So let us take a key 25 and check it. Key is 25. Low, high and mid. These are the 3 values we need. Low starts from here, high starts from here. Now first mid value is 7, so 0, 14 and 7, mid is here. Now is it a key? Key is 25, so this is not 25, 25 is smaller, so check on the left hand side. So move high to 6, 7 minus 1, that is 6, and this is 0. Now mid is 3. Go to mid of this one, so this is the middle of this list. From low to high, this is the middle one. Is it the element that we are looking for? 25. 25 is greater. So check on the right hand side. So this will be new low, that is mid plus 1. Low becomes 4 and high remains 6. Now find out mid, that is 5. So this is mid. Now, is it the number that we are searching for? 21? No. 25 is greater than that. So 25 is on the right hand side. So modify this low and low also becomes 6, that is mid plus 1. So 5 plus 1, this is also 6 and this is also 6. Find mid, this is 6. So right now, low and high and mid, all of them are on 6. Now, is it the element that we are checking for? 25? No, 25 is greater. So modify low. If it is greater, we'll modify low. So low will become what? Mid plus 1. So what is mid right now? It is 6. So low will become 7. So mid plus 1, low will become 7 and high is 6 only. Now we will stop. We will not find mid now, we will stop. Reason, low has became greater than high. Low has became greater than high. Low should be on the left hand side and high should be on the right hand side. But low became greater than high. So it means the element is not there in the list. So search is unsuccessful. So this search is unsuccessful. So these 2 keys were found and they were there in the list. 25 is not there in the list. Now let us see how many comparisons it has taken. 1, 2, 3, 4. 4 comparisons, and here we don't do anything. Stop. So in 4 comparison we got the result that element is not there. So this is how binary search works. Now let us write the algorithm for this one.